Dear students, we are going to discuss CPM and PERT in 4 parts. Part 1, we will discuss network diagram. Part 2, we will be discussing critical path method. In part 3, we will be discussing performance evaluation and review technique. And finally, in part 4, we will be doing crashing of your project network. Now we will see network diagram. This is called an event or node. N is a node number. E stands for the earliest starting time for this event. L stands for the latest completion time for this event. This is an arrow or arc, and it represents an activity B here. And this is the ending node for the activity, as E stands for the earliest starting time for this event. L stands for the latest completion time for this event. N is the node number of this event. Now, your project has many activities. An event occurs before and after the end of an activity as shown here. Now, this is starting event and ending event. All events need to be completed in sequence as shown in the network. Since a project has many activities, very many number of events will be there. All the events should be completed in the sequence as shown in the network diagram. We will see the guidelines for network diagram construction. This is an activity I am showing here. The starting event and ending event of an activity are called tail event and head event respectively. So this one is the tail event, event before the activity starts. The event after the end of the activity, this is head event. The network should have a unique starting node tail event, as I have shown here. The entire project network should have a unique starting node. It's called tail event. The network should have a unique completion node. As I showed the starting event, there should also be an ending node, that is the completion node called head event. Only unique it should be. There should not be two ending events for a network. No activity should be represented by more than one arrow in the network. We will see here. See, an activity A is here. It cannot be represented by two arrows here. Only one arrow should represent one activity. No two activities should have the same starting node and ending node. Please note here, this is the complement of this. So activity A and B cannot be represented by the same arrow. So no two arrows can represent the same activity, or no two activities can be represented by the same arrow. Dummy activity is an imaginary activity indicating the precedence relationship only. Please note that dummy activity I have shown here only to show the relationship between C, A and B. A and B are combined predecessors to activity C. C should start only after A and B are completed. Therefore, I used a dummy activity. It has got no time duration. Mistakes you must not make. Looping error. Please note that a project should have unique starting event and unique ending event. You've got a unique starting event, but no unique ending event is there. It cannot be same. Starting and ending event cannot be same. Then it is a looping. Dangling error. Please note that here the activity B is dangling because this event is not completed. It has got two ending events for this network. It should not be there. There should be one ending event, either this or this, right? Therefore, I join this by a arrow. This is a line. It does not represent any activity. It only completes the network. This arrow can also be vertical, also downwards. If the arrow is upwards, then it is again dangling. Because this is not completed, there will be two end events here. This also will be only end node. This also will be another end node if the arrow is upwards. If the arrow is downwards, then what happens? It completes. There is only one end node there. Redundancy. Please note here, this B and C are predecessors to D, as shown here. B and C are predecessors to C. But I cannot use two dummy activities to represent this because I can use only one dummy activity for representing the same thing. Therefore, this redundancy should be avoided. Right? Finally, flouting the precedence rules. Whenever the predecessor rules are there, this should be followed strictly. I will see problem. Now, tail event, activity, head event. We know that this is the way we are representing the network. A is precedence to B and C activities here. C and is precedence to B, A is precedence to C. D and E are combined predecessors to F activity. D and E are combined predecessors. Therefore, we can join these two activities by a common end node. See here, A is the starting activity. B has got precedence A. C has got precedence A. And then D and E are to be combined here as predecessor. Therefore, D has got precedence B, E has got precedence C as shown here. Okay, E has got precedence C shown here. D has got precedence B shown here. And now F has got precedence D and E. So this completes the network. So whenever they are combined predecessors, then they can be joined with a common end node here. Problem 2, we will see activities predecessors shown here. A and C are lone predecessors for these activities E and F, as well as combined predecessors for D. Therefore, we should use a dummy activity. We will see how we are going to use. A, B, and C are starting activities. Okay. D has got A, B, C, all the three. Therefore, I am using dummy activities here. Why I am using two dummy activities? Because E and F are having a lone predecessors A and C. So A and C are combined predecessors as well as lone predecessors. Therefore, I have to have two dummy activities. And D has got combined predecessors of A, B, and C. Okay, this completes C. And G has got D, E, F as a combined predecessors. Okay, so this completes the project network for this table. Now we will see here in this case, A and B are starting activities with no predecessors. C has got predecessor A, and we will see E has got predecessor B. Therefore, I have drawn this first. D has got predecessor A and B on lone predecessors as well as combined predecessors. Therefore, I have to use two dummy activities here. We'll see here. I use two dummy activities. So D, because D has got combined predecessors A and B. Okay. Now F and G are combined predecessors to H and I activities. F and G are here combined predecessors to H as well as I activities. So here, therefore, F and G are combined with their common end node. Okay. F is got C as a predecessor. G has got D as a predecessor. This also tallies. Now H I have to draw here. I have drawn here H with combined predecessors F and G. I has got combined predecessors F and G. Therefore, I have to see that I is drawn here. I has got combined predecessors F and G. Okay, so E and H are combined predecessors to J activities. See, E and H are combined predecessors to J activities. I and J are not predecessors to any activity, therefore end activities, and I have combined here. I and J are end activities, I have combined here. This completes the project network for this table. We will see the next problem. Two activities cannot start from the same node and end in the same node. We know that. Activity H has got only E as a predecessor. We will see why we are talking particularly about this. Activity I has only F as a predecessor, right? Whereas G has got D, E, F as a predecessor. G has got D, E, F as a predecessor. So E and F are lone predecessors as well as combined predecessors. That is what I've stated by these two statements. E and F are lone predecessors as well as combined predecessors, right? From this, we will see here A is a starting activity. B has got a predecessor A, C has got a predecessor A, D also has got a predecessor A, and E also has got a predecessor A. Okay, we have shown this. Now we will see here F has got a predecessors B and C. Therefore, I use a dummy activity here. And you see here I has got a here combined lone predecessor F, whereas G has got a combined predecessors. Therefore, D, E, F are combined. Please here F is combined with the dummy activity. E is combined with the dummy activity here. B is this here as a predecessor directly. Therefore, D, E, F are combined predecessors to G. And then I, G, H are combined predecessors to J. Right? I think this completes the project network for this table. We'll go to the next problem. Here A and B are starting activities. C has got A as a predecessor. D and E are combined because D and E are combined predecessors to G. D has got predecessor A, E has got predecessor B, tallies. And G and F are combined predecessors to H. Therefore, G has got a predecessor D and E, ensured. F has got a predecessor B, ensured. Please note that E is an arrow upward, therefore it is not a predecessor. Now H has got a predecessor F and G, right? Now this is dangling, therefore I must, even 6 is dangling, therefore I must join this. This completes the project network for this table. We will see next problem. Here A and B are starting activities, no predecessors. C has got A and B as a predecessor. A and B are combined predecessors to D activity here, right? We'll see here. Therefore, A and B are combined predecessors with one dummy activity I have shown there. D and E are combined predecessors. Therefore, I am joining with a single node, end node. Okay, and F is D and E has got, so I will join F there. D and E are combined. This is to F and H activities. You will see here. C is drawn. F is drawn here because F and C are combined predecessors. I have joined these two. C and F are combined predecessors to G. Right. C and F are combined predecessors to G here. Therefore, G has got a predecessor C and F. H has got a predecessor D and E. Right. So I has got a predecessor G and H. Therefore, I'm drawing it to complete their project network. Right. We will see problem 7. I got a lot number of activities. Therefore, I have drawn it horizontally. We will see here A, B, C are starting activities. D has got a predecessor B, and C and D are combined predecessors here, C to H. Therefore, I have drawn it here. And E has got a predecessor to A, F has got a predecessor to A, I have drawn it here. G has got a predecessor to B here, right? But note that F, G, H are combined predecessors, right? So F, G, H are combined predecessors. I have drawn it with a combined common end node. Now I has got a predecessor to I has got a predecessor to I has got predecessor C and D here. Okay. Yeah. J has got a predecessor only E here, so I'll draw J. And then K has got a predecessor F, G, H, so I'll draw here K. K and J are predecessors. See here at N, yeah. Therefore they are combined to a common end node. And L has got a predecessor F, G, H here, shown here. Therefore it is drawn here. M has got only I as a predecessor, right? And N has got J and K as a predecessor, so I will draw here N. And since M and N are end activities, L also is end activities. I will join L, M, and N together as a unique end node for the project. Please go through this project network and the predecessor rules. Then we will discuss also in the class. Now, problem 8, we will see A and B are starting activities. C has got A and B as combined predecessors, but I'm using two dummy activities for reason. Please note, D has got B as a lone, and similarly, E has got A as a predecessor, lone predecessor. That's why I used two dummy activities. So A and B are combined predecessor as well as lone predecessors. Right? C has got a combined predecessors A and B. F has got a predecessor C, drawn it here. And G has got E and F as a predecessor. Therefore, I have to use a dummy. Yeah, I use a dummy and G as a predecessor F and E. And then H has got a predecessor D and F. And G and H are combined predecessors. Therefore, I'm just going to draw this with a combined common node. So H has got a predecessor D and F here. You can see that here. So that is why we are using two dummy activities here, not redundant. It is required. And then I has got G and H as a predecessor, and J has got I as a predecessor. This completes the network for this problem. Problem 9, we will see here A and B are starting activities. C has got A is a preceding activity, D has got preceding activities, but C and D are combined. Therefore, I am combining this combined predecessors to G. You will see here E has got A as predecessor, lone predecessor. F has got B as a lone predecessor, and G has got C and D as a combined predecessor. I have shown. H has got G and F as combined predecessors, but H and I are combined predecessors, and I has got E as a lone predecessor. Therefore, I am combining I and H here together with a common node. And then J has got H and I as a common predecessor, and K has got a predecessor J. This completes the project network for this table. We'll see the next problem. See, number of activities are more. Therefore, I've shown a horizontal table. A, B are starting activities. C has got B as the lone preceder. D has got C as a lone preceder. E has got A and D as a preceder. That's why I've drawn these through close so that it will come after the vertical left to right, it will go arrow. Clear? So you know the purpose of my drawing too close. The duration may be larger than A duration. Now F has got D as a predecessor. G has got A and D as a predecessor. Therefore, A and D as a thing. So I have to draw this. G has got A and D as a predecessor. Okay. Then I has got H as a G and H as a predecessor, right? G and H. Therefore, G I have drawn a dummy activity to combine G and H here. I. Okay. And then J has got I as a predecessor. K has got G as a predecessor. And J and K are combined predecessor to L. That's why I'm using a common node here, end node. And then J and K, I'll have to draw L here, right? Okay. L has got J and K as a predecessor. M has got L as a predecessor. I've drawn it here. And this is dangling. F is dangling here. F is no predecessor anywhere. Therefore, I have to combine this to complete the project network diagram. Okay. Go through this activity diagram as well as the preceding rules here. Now, this problem we will see here. A is starting activity, no predecessor. B and C and D are having A as a predecessor. So B, C, and D are the same. Then we will see that E has got D and C as a predecessor. We will see F has got A as a predecessor, lone predecessor. Therefore, F I have drawn it first. Now, C and D are predecessor to E. Therefore, I use a dummy variable here. B and E are combined predecessors. Therefore, I join B here with a dummy variable. So I have drawn G here. H, B, and F. See, B and F are combined. Therefore, I'm using a dummy variable here. And I'm using G over here. G and H are combined predecessor to I. So I have drawn here. This completes the project network for. Okay. Now we will go for a recap quiz. So this is right or wrong? This is wrong because an activity cannot be represented by two arrows. Each activity is represented by one and only one arc or arrow. This one is correct because correct or wrong. This is correct because this is perfectly all right. A is one activity drawn by this arrow. B is another activity represented by this arrow. Now here, two activities cannot have same starting and ending row. Therefore, this is wrong. Right? This is wrong. No two activities can be represented by the same start and end events. Now here, is this correct or wrong? This is correct, perfectly right. C has got A and B as a combined predecessors. Therefore, I'm using a dummy activity which is required. No redundancy, correct or wrong? See this here, we'll see here. So see A and B are predecessors to C, which is followed here. Okay, correct. Whenever a new activity is added to the network, we must see the following precedence relationship. What are they? We will see. One is what activity must be completed immediately before this activity can start. That is predecessors. What is the preceding activity? Immediately preceding activity. What is the immediately succeeding activity is the next question. What activity must follow immediately after completion of this activity? Right? What activity can simultaneously occur with this activity? These are all the three questions we must see. Answer is there or not. Arrows should not cross each other. Ensure that there are no crossing of arrows. Always use straight arrows. Do not scale the arrow length with the duration of the activity. As I told you earlier that the length of the arrow and the duration of the activity are not at all related. Your long duration activity can be represented by a small arrow. Your long arrow can represent a small duration activity. Use arrows from left to right only. Right? So you can space the events such a way so that you are having arrows from left to right always. Use dummy arrows only when essential. Remove redundant arrows. Right? There should not be any unnecessary arrows there. I hope you have benefited from this video. In case you have benefited, please tell your friends also. And recommend to your friends so that they will also benefit. Thank you very much. You can subscribe also and like my video if you like the video.